Good afternoon and welcome back to the Harbor Hangar. I finally have the hangar in a workable state again, and I owe you a walk around and talk around of the A26. So let's go do that. A quick overview for those of you just joining us in the hangar. This is my 1/4 scale model of the Douglas A26 Invader. 1/4 scale means 17.5 foot wingspan. The weight I will tell you in a minute, but quick shout out to the main sponsor over there, Windcatcher RC, windcatcherrc.com. He is awesome. He is quite possibly crazier than me for getting involved with this build because he hot wired all of the styrofoam that's inside this plane and donated all the carbon fiber and wiring. Yeah, go check out Windcatcher if you need carbon fiber and wire and other RC supplies. Batteries, yes, also sponsored the batteries for this and the C47. Anyway, got to give some love to Windcatcher. A26 is also supported by Flight Test and Zorprops and FR Sky. FR Sky is the radio system in this big bird, and I'll get around to that as well. I said I would tell you about the CG, and so let's do that now. The two tape marks you can see on the fuselage here and over there are where I put a scale underneath the fuselage so that I could get the total weight and then the fractional distribution of the weight so that I can get a CG measurement that I can reference to my CAD model and get an idea of where the CG is for this big bird, because you can't really balance this thing on your fingers and figure out the CG. So total weight on this bird is about 93 pounds. Yes, unfortunately, I busted through the LMA1 and the LMA2 thresholds on this one. I was hoping, praying that I could keep it down at the 55-pound mark, but I guess I just don't build that way. I did kind of definitely overdo the sizing on the foam, which foam doesn't weigh a lot by itself, but when you add it up, it adds up. So anyway, that is what it is. We can still fly at our local field. We can fly at Flight Fest, and I gotta go into the LMA2 thing if I want to fly at CEF. Anyway, the good news is the weight distribution is such that with all of the batteries and motors and props and everything, it is nose heavy by about 2 inches forward of even my, or no, like 3 inches forward of my calculated forward limit, my forward static margin. We're still not done adding stuff, and there is some stuff to add to the tail, so that should bring it back. We'll have to redo the weight and CG once everything is really done, but this is pretty much close. It's basically ready to fly, except for markings and a few little mounts on the tail. So good that we are nose heavy. Where do the batteries go? I'm glad you asked. These cowls here go on with magnets, just like that. I love this thing. It took a little bit of extra time on this one versus the C47 to make it so that things click on with magnets a lot easier, and so I don't have to be taping hatches and stuff like that. Actually, this doesn't have to come off. We can actually leave the cowl on and open the battery hatch like that. I love it. So this hole right here is where we stuff batteries. 4 6000 6S batteries go in there for a combined series parallel pack equivalent of a 12,000 12S LiPo powering this monstrosity. Well, that is what powers each motor. So technically the whole airplane has the equivalent of a 24,000 12S powering the main power system. Then up in nose, we have the avionics bay, avionics corner. This is where we're going to shove, right now they're just sitting in here, but we've got a bunch of little 2 cells that will be distributed to power the servos and receivers and retracts. Retracts. I'll get to that in another minute. But first, I want to show you the brains of the system. This is a wiry mess. But underneath this wiry mess, which I still am in the process of cleaning up, is the FrSky RB40. Ooh. So thank you, FrSky, for loaning me this. This is going to distribute all of the functions to the airplane and provide power distribution for the main flight controls and provide redundancy function for 3 receivers. So we'll have 2 separated up here in the nose and then 1 way over there in the tail. Yes, I wanted to put 1 in each wingtip and 1 in the tail, but as I was constructing the wings, I forgot to run the wires, and now that is going to be a big pain in the butt, so we're not going to do that. It'll be fine. Okay, as I said, we're going to distribute all of the controls and powers to the main flight controls, which is ailerons and elevator and rudder and nose wheel steering. Yes, it steers. Woo! The power to the retracts for all 3 retracts will be direct powered because they need a lot more juice to operate. So I'm not going to run the voltage for the retracts through this guy. They're going to have direct power, just so we know that the retracts definitely have the power they need. The rest of the servos aren't going to draw near as much current compared to the retracts. So all those are going to go through the RB40, and the main channels that the flight controls go through actually have current monitoring and over voltage protection, so that if any one of them like crap out, then the RB40 will protect the other servos from getting like shorted or overdrawn, and also the receivers, so one surface won't take out your whole plane. Continuing the walk around, what is this thing covered with? Is it duct tape? Is it shiny silver foil? Nope. It is iron-on silver Monocoat. And a big shout out now to Mike, Glenn, Tanya, Jeremy, and Scott, and whoever else donated Monocoat for this baby. Specifically Jeremy at the Model Box in Birmingham, Model Box 2.0. They ordered, and Birmingham RC Club people combined with Model Box, they bought 4 rolls of silver Monocoat that is blowing out my camera. And so far we used 3 of them, so I have 1 more roll for spare and repairs. But Mike, Glenn, and Tanya specifically, thank you guys for coming over. They helped me cover and get the ball rolling on covering the fuselage. And also my son. Thank you, Mike, for working with my son and helping to teach him and start him on the covering, because my son then helped me continue on and finish the wings and do the nacelles. It was probably a week total of covering. Well, I'm thanking people like Mike. He is the guy who welded this beautiful landing gear together. I don't have it powered up, but I can show you how it moves. It's super cool. The wheels go up inside and they fit and everything, and then they come down and they lock in place, and I couldn't have done it without my buddy Mike, so thank you, man. This is where the tail receiver is gonna go, somewhere up in here somewheres. Right now it's just sitting there, but it's all wired in. We've verified that. Thank you, Adrian, for getting all those bound at Flight Fest. He was super awesome in so many different ways, but specifically in this particular instance, he got all of the receivers bound up because I was redshirting and distracted and doing a bunch of other stuff. Thanks, dude. How are the wings held on? Well, gosh, I'm glad you asked that too. Before I get to that, let me tell you about how the fuselage is constructed. As I mentioned, it's styrofoam, hot wire cut. Thank you, Windcatcher RC. But it's not just styrofoam glued together. Through the entire length of this fuselage and down the wings, there are a bunch of carbon tubes. If you can imagine, basically in the corner area of this fuselage, at all 4 corners, because it's not quite round, it's kind of a rounded rectangle. Rectangle? In the 4 corner regions of the fuselage is a carbon tube that runs the entire length. There are 2 up here, and then as it goes forward, where the cockpit goes down, they transition, and there's 2 more on either side. So 4 total that go forward into the nose, and then 4 that continue down the length of the fuselage to about here. And then these 4 taper and transition to 3 in the tail section of the fuselage, where there's 2 in the top and 1 in the bottom, all the way back to about here, where there's some wood plates that terminate in the tail mount structure. The horizontal and vertical each have a carbon tube right here and right there in the center, and that's how those are attached. The wing also has its own set of carbon tubes that form the spar system. So 2 carbon tubes in front, 2 in the rear, top and bottom, and those go out the entire length and taper and telescope all the way down. There's also one in the leading edge for leading edge protection and just general added stiffness for torsion and all that stuff. So that is how all the pieces are internally constructed, but how do we join them? Well, right down in here, I don't think you can maybe see, but maybe we can. Yep, can we see? There are 2 aluminum tubes. Let's go to the front. So as you can see, the A26 has got some considerable dihedral. I don't remember what the angle is off the top of my head, but it's not 0. So each wing is coming in at an angle that's not straight. So the carbon tubes on this side and this side are coming in at a downward angle. But the fuselage wants to have something go straight across to join them. I've got 2 aluminum tubes that go straight across. They go from about the outside of the nacelle all the way through this wing, through the fuselage, through that wing, into the nacelle, because there's a bunch of wood structure in there. So we've got aluminum tube picking up wood structure here, going through wood ribs in this portion of the wing, through some wood reinforcements in the foam in the fuselage, back through some wood ribs, into the wood structure on this nacelle. This wood structure also is connected to the landing gear on both sides. So our main flight and landing loads and everything are all tied in through this wood structure, through the aluminum spars into that one, and so it's all nice and connected. And that is how we get wing join with dihedral and a simple across the center spar load, and there you go. Yes, the A26 is far easier to assemble out of the trailer than the C-47 was. You might say I learned a few things from my previous Giant. I learned a ton from that C-47. Holy cow, that could be an episode in and of itself. If you actually, there's a thought. If you would like to hear sort of my lists of lessons learned from C-47 to A26, not just limited to construction, but construction and flight and transport, let me know if that would be interesting to you, and I'll think about doing an episode on lessons learned. That sounds like a pretty good idea, to me anyways. Let me know. Okay, it is starting to get warm and muggy here in northern Alabama, so I'm going to wrap it up and say thank you all for hanging out with me in the Harbor Hangar and following along. Thank you so much to all of the sponsors and supporters of this project. This is not a one-man show. I could not do this alone by any stretch. Thank you to Flight Test. Thank you to Zor for the props. Thank you to FR Sky for the radio system and helping me out when my radio died. Thank you to Windcatcher RC, chiefly for batteries, wires, carbon, and the cutting of this monstrosity out of foam. And as always, thank you so much to my awesome family, chiefly my lovely wife and our awesome son, for putting up with me and helping me so much on this project. Couldn't do it without the support of you guys. All right, enough of that. See you next time. Let me know what other questions you have on the A26 and other things, and I'll do my best to answer them if I didn't in this episode. See you later. Bye.